the chemistry online class. Hope you all are fine and safe. Today we will have an exhaustive session for the definitions and terminologies in the chemistry part of standard 9 science. For the chemistry part we have only 3 chapters. Chapter 2 is matter around us pure. Chapter 3 atoms and molecules, and chapter 4 structure of the atom. Chapter 1 is completely omitted and we have few omissions in chapter 2, 3, 4 as well. The few omissions in chapter 2, 3, 4 I have already discussed in the video as well as in the Zoom interactive session. Now today we will see only the definitions and terminologies from all the 3 chapters. You can take down in your classwork the definitions so that it will be helpful for you. Shall we go to the session now? So first we will start from chapter 2 is matter around us pure. In this chapter the first definition is what is a mixture. Now mixture is constituted by more than one form of matter. That is, if I say mixture, it will consist of more than one state of matter, kind of particle of matter. Whereas if I say pure substance, it is only one form of matter. So this is the difference between pure substance and impure substance. The impure substance is nothing but mixture which will contain more than one kind of form of matter. The next one is what is compound. Now mixture is a combination of more than one type of particles. Similarly, compound is also a combination of more than one or two particles of matter. But the difference between mixture and compound is there will be combination of particles in a fixed ratio, that is in a uniform composition. In a fixed ratio there will be combination, whereas in a mixture there will be no uniform composition. So compound is a combination of two or more substances in a fixed ratio. Now the next one is true solution. What is a true solution? As the name indicates, it is a true solution means that it will contain uniform composition throughout the system. That is a true solution. True solution is a homogeneous mixture which has a uniform composition throughout the system. Examples are lemon water, salt water, all this, which will be completely dissolved in water. The salt completely gets dissolved in water to form salt water which has a uniform composition throughout the system. That is called true solution. Next one is colloid. What is a colloid? Colloid is a heterogeneous mixture. That is, it does not have a uniform composition. Similar to true solution, this colloid will not have a uniform composition throughout the system. Thus it is a heterogeneous mixture. And the particle size is comparatively greater than the particle size in a true solution. The similarity between a true solution and colloid is both will pass through the filter paper. That is, you cannot filter the particles inside the true solution and a colloid. So that is the only similarity between true solution and colloid. Colloid examples are milk, blood, etc. The next one is suspension. To understand suspension, you should know what is solute and solvent. Though solution part is entirely omitted from the revised syllabus, you should know what is a solute and what is a solvent. Solute plus solvent gives solution. Solute is a substance which should be in a lesser quantity and solvent is a substance should be in a larger quantity. This solute will get dissolved in the solvent only to form solution. For example, solute is salt and solvent is water. So salt dissolves in water to form salt water. So this is how a solution forms. Now in suspension, suspension is a heterogeneous mixture where this solute will not at all get dissolved in the solvent. For example, mud water. Mud will not get dissolved at all in water. How many times you dissolve mud in water, it will sediment down. That is what a suspension is. How many times we dissolve the solute, it will not get dissolved in the solvent at all. So suspension is a heterogeneous mixture where the solute will not get dissolved in the solvent. Since there is no dissolving process there, we can easily see the particles of the solute through naked eye, and we can filter it also. So this is how a suspension is formed. Next, in the same chapter, we will go for the separation techniques. We have 8 separation techniques, that is evaporation, sublimation, decantation, centrifugation, chromatography, simple distillation, fractional distillation and crystallization. Now, when the separation techniques are asked in your exam, the first thing what you should do is, you should write the principle of each technique first. Then you should explain the technique, and then you should draw the diagram if necessary, depending on the marks for the question allocated. Now we will go to the separation technique. The first separation technique is evaporation. Now the principle of evaporation is, the evaporation is a process of conversion of water to water vapor, liquid to gaseous form. That is what evaporation is. Now in evaporation, what exactly happens is, the volatile solvent is removed from the non-volatile solute. Now the solvent, which is volatile in nature, will absorb energy from the surroundings, or it will absorb the energy given to the process and it moves to the vapor state. But the non-volatile solute will remain in the system itself. So volatile solvent will go as gaseous state and it will disappear. The non-volatile solute will be in the system itself. That's how you can separate the solute and the solvent. So the first technique what we discussed now is evaporation. The second technique is centrifugation. For this we use a centrifugator. Centrifugation involves the principle of density. Just remember the key word for density as thickness. The denser particles will go down and the lighter particles will come up when we spin the system continuously. This is what the principle of centrifugation. The denser particles settle down and the lighter particles move up when the system is continuously spinned. Thereby we can separate the lighter impurities and the denser particles by the process of centrifugation. The next technique is decantation. This decantation technique is performed using the apparatus called separating funnel. This figure is given in the textbook also. Now, whenever we say decantation, we should remember one important keyword, that is immiscible liquids. What is immiscible liquids? The liquids which will not mix together at all. For example, oil and water. We cannot mix oil with water. That is immiscible liquids. Now, if unknowingly or unfortunately oil is spilled in water, how can we separate it? Using a separating funnel. Now, when we use a separating funnel, when we pour this immiscible liquid mixture to the separating funnel, what exactly happens is, which is denser, oil will be thicker. That is, it is denser compared to water. So, when we pour the contents, that is oil and water, in the separating funnel, the lesser denser water will flow down and the oil will stay up. Thereby you can separate the water and the oil. So by the process of decantation, we can separate immiscible liquids. The fourth technique is called sublimation. Sublimation is a process where there is conversion of solid state directly to gaseous state without going through the liquid state. Sublimation is used to separate mixtures that contain a sublimable volatile component and a non-sublimable impurity. Some examples of solids which sublime are ammonium chloride, naphthalene and anthracene. Camphor is also known as ammonium chloride. Now the fifth technique is chromatography. Chromatography is a technique where you can separate two or more solutes which can dissolve in the same solvent. For example, ink. Ink will dissolve in water to form dye. Now, if I mix 2-3 ink colors in water, it will form a separate dye. Now, if I want to separate all the inks from the water, I can go by the process of chromatography. By change in color, you can separate the solutes present in the same solvent. So this is the principle involved in chromatography, where we can separate two or more solutes which are dissolved in the same solvent. The next technique is simple distillation. Simple distillation, now we were talking about decantation. Decantation is the separation of immiscible liquids. Now we will talk about miscible liquids. If two or more liquids which can mix with each other are already mixed, now we are going to separate it by the process of simple distillation. In simple distillation, we can separate miscible liquids. The condition is the difference between the boiling points of each liquid should be more than 25 Kelvin, so that we can easily separate each liquid from a miscible liquid mixture. So for this we use the process of simple distillation. Now the seventh technique is fractional distillation. In simple distillation, I told you that we can separate miscible liquids whose difference in boiling points is more than 25 Kelvin. What will happen if the difference in boiling point is less than 25 Kelvin? It will be very tough to separate the liquids. For that separation, we use a separate fractionating column in the simple distillation setup. In the same simple distillation setup, we will just add one fractionating column so that we can separate liquids whose difference in boiling points is below 25 Kelvin also. So that is the principle of fractional distillation, where we can use an additional apparatus, that is fractionating column. The last technique, separation technique, is crystallization. This technique is used to get pure solids. By crystallization, the pure solid is obtained. This is the major use of crystallization. So by the process of crystallization, what will happen is the impurities will settle down and the pure solids can be crystallized out. This is the principle behind crystallization, where we can obtain pure solids. So these are the only definitions and principles involved in chapter 2. Now we will move on to chapter 3, atoms and molecules. In this chapter, the first definition, what is law of conservation of mass? The answer is mass can neither be created nor be destroyed. This is law of conservation of mass. What is the meaning is, whatever mass of the reactant, that is ingredient, you take, the same mass will be obtained as product. The compounds might change, but the mass will remain the same. That is law of conservation of mass. Mass can neither be created nor be destroyed. The next one is law of constant or definite proportion. By the name itself, we can say the elements present in a substance will be always in a constant or definite proportion, that is ratio by mass. That is the law of constant or definite proportion. The next one is atomic radius. What is atomic radius? Atomic radius is the distance from the center of the atom, that is nucleus, till the last shell of the atom. That distance is the atomic radius. This atomic radius is measured in nanometers, that is 10 to the power of 9 meters. That is how atomic radius is measured. The next one is expand IUPAC. IUPAC, the full form is International Union of Pure and Applied Chemistry. This organization is a US based organization. This organization is an international organization which approves the names, symbols and units of all the elements which are invented till date. So IUPAC is abbreviation is International Union of Pure and Applied Chemistry. Next one, what is atomic mass? As the name indicates, it is mass of the atom. Now the mass of one atom, as atom is very tiny, we cannot see an atom through naked eye. How can we determine the mass of the atom? So we will take a standard atom, that is carbon 12. Carbon 12 atom is the standard atom. Now the mass of one atom is exactly equal to 1/12 the mass of the carbon atom. This is how we can find atomic mass. So atomic mass is the mass exactly equal to 1/12 the mass of the carbon 12 atom. The next one is a very important question. What is a molecule? Molecule is formed by combination of two or more atoms. When two or more atoms combine together, it form a molecule. Now under molecule we have what is molecule of element and what is molecule of compound. Molecule of element is a molecule which is formed by same kind of atoms. Example, O2 molecule, N2 molecule. N2 means two atoms of nitrogen, only nitrogen combined to form the nitrogen molecule. So molecule of element is formed when there is a combination of same type of atoms of same element. Now what is molecule of compound? Obviously the atoms of different elements combine together to form molecule of compound. Example, water. Water formula H2O. Now in H2O we have two atoms of hydrogen and one atom of oxygen. Hydrogen is different, oxygen is different. Now the three atoms combine together to form the water molecule. So molecule of compound is a combination of two or more atoms of different elements, whereas molecule of element is a combination of two or more atoms of the same element. The next one is atomicity. This atomicity is again a very important question. What is atomicity? Atomicity is the total number of atoms present in a molecule. Either it is molecule of element or molecule of compound. If you add all the atoms, you will get the atomicity. Now to add the atoms, if you can see a subscript, in the compound, you can count it. If there is no subscript, you should imagine that there is only one atom. So if there is no subscript, you can put 1. If there is subscript, you can add it. So for example, if I say water, H2O, for O there is no subscript. But for H we have subscript of 2. So 2 plus 1 gives 3. The atomicity of water is 3. This is how you should derive the atomicity. Now the next definition is what is an ion? Ion is a charged species of the atom. The atom, when it carries a charge, it is called ion. Under ion we have what is cation, what is anion. The positively charged species is called cation and the negatively charged species is called anion. So ion is further divided into cation positive, anion negative. Now what is a monoatomic ion and what is a polyatomic ion? Monoatomic, mono means one, atomic is atom. So only one atom of any one element, when it carries a charge, it is monoatomic ion. Now polyatomic ion is when a group of atoms carry a overall charge, it is called polyatomic ion. There is a tabular column given in chapter 3, atoms and molecules. You can refer the examples for monoatomic ion and polyatomic ion. The next one is what is molecular mass? Now molecular mass, you should understand the concept of atomic mass. What is atom? Atom is the basic form of matter and molecule is the combination of atoms. Two or more atoms combined together to form a molecule. Now if I add all the masses, atoms masses, that is if I sum up all the atomic masses, I will get the molecular mass. Yes. Molecular mass is defined as the sum of all atomic masses present in the substance. This is called molecular mass. The next one is what is formula unit mass? Formula unit mass is the sum of all the atomic masses given in one formula unit of the compound. Say for example, only one unit of the compound, the atomic masses if you add, you will get the formula unit mass, that is also a molecular mass only. Next one is what is a mole? Mole is the 1 mole. For example, if I say 1 mole, that 1 mole is equal to the atomic mass or the molecular mass. So 1 mole is the mass which is equal to the atomic mass or the molecular mass of a particular compound, molecule of element or molecule of compound also. Now the next one is what is Avogadro number? This Avogadro number is a constant denoted by the letter N naught, that is N subscript 0. Since it is a constant, it does not have a unit at all. Now this Avogadro number, the value is 6.022 into 10 to the power of 23. The 6.022 into 10 to the power of 23 is the value of 1 mole. Now 1 mole will contain 6.022 into 10 to the power of 23 particles. Now this 1 mole, I can say it as atomic mass or molecular mass. So 1 mole is equal to atomic mass or molecular mass, which is in turn equal to the Avogadro constant, that is 6.022 into 10 to the power of 23 particles. And Avogadro number is denoted by the letter capital N naught. Chapter 4, Structure of the Atom. In this chapter we have many definitions. The first one is, what are canal rays? Now to understand canal rays, you should understand how the atom is divided. Now in canal rays, what exactly happened is, initially we found that the atoms are indivisible because they are basic form of matter. But later what happened? When electricity is passed through a big or large discharge tube, there were radiations coming out of the discharge tube. And these radiations were positively charged. Yes, those radiations are called canal rays. So canal rays are the positively charged radiations which were emitted from the gas discharge tube are called canal rays. This canal rays was invented by the scientist E. Next one, what is a proton? Now proton is a subatomic particle. Since there was a discovery of canal rays, and this proton was invented by the same scientist E. Goldstein. Since he discovered canal rays, he in turn discovered proton, a positively charged subatomic particle present inside the atom, which is denoted by the letter small p, invented by E. Goldstein. Now the next one is, what is an electron? Now since we have a positive particle proton, obviously we will have a negative particle also, because positive and negative will get cancelled and the atom will be neutral. So the negatively charged particle present inside the atom is called electron. Electron is denoted by the letter small e, and electron was discovered by J.J. Thomson. Next one is, what is neutron? Neutron, as the name indicates, it is neutrally charged, that is no charge at all. Neutron is the third subatomic particle present inside the atom which carries no charge. This neutron was invented by the scientist J. Chadwick. The next one is, what is valency and what is valence electrons? To understand valency and valence electrons, you should know the structure of the atom, which is proposed by Niels Bohr. It is also given in the textbook, the figure. Now, when I take an atom, the center of the atom is the nucleus. Inside the nucleus, we have two subatomic particles, protons and neutrons. Outside the nucleus, we have orbits on which electrons are revolving. Now, valency is the combining capacity of the atom to form bonds with other atoms of the same element or the different element. That is how the bonding takes place and the elements react with each other. So, valency is the combining capacity of one particular atom to react with atoms of same element or the different elements. Next is, what is valence electrons? I told you that in the structure of the atom, at the center we have nucleus. Inside the nucleus we have protons and neutrons, and electrons are revolving around the nucleus in circular orbits. Now, valence shell you should know when we learn about valence electron. Valence shell is the last shell present in the atom. So, valence shell is also called as last shell, outermost shell, ultimate shell. All these terms we can use. Now, the electrons which are present only in the valence shell of an atom are called valence electrons. So, these valence electrons only will take part in the reaction first. That is called valency. While valence electrons react with each other, with the concept of valency, the bond is formed. That is called valence electrons and valency relationship. The next one is atomic number. Now, atomic number is the total number of protons present inside the nucleus of an atom. Atomic number is denoted by the letter capital Z. Now, if the number of protons is 20, for example, how many will be the number of electrons? Absolutely. Number of electrons will also be 20 because plus 20 proton minus 20 electron, it will keep the atom neutral. So, always the number of protons is equal to the number of electrons. So, atomic number you can define as number of protons present inside the nucleus of an atom or the number of electrons that are revolving around the nucleus of an atom. Both the numbers will be same, but they are opposite in charges, proton plus, electron minus. Now, the next one is mass number. Mass number, as the name indicates, it is related to the mass. Now, the mass of the atom is determined by the mass of the nucleus because nucleus determines the mass of one atom because it contains protons and neutrons. Therefore, mass number is equal to number of protons plus number of neutrons present inside the nucleus. Mass number is denoted by the letter capital A. Now, how will you represent an element with atomic number mass number is, atomic number will be denoted in the left subscript of an atom and mass number will be denoted in the left superscript of an atom of particular element. So, when you represent X as an element, Z, the atomic number will be in the left subscript and mass number will be in the left superscript. This is how we will represent an element with atomic number and mass number. The next concept is isotope and isobar. Now, isotopes are atoms of the same element with the same atomic number but different mass number. So, Z will be same but A will be different for isotopes. Now, in isobar, Z will be different and A will be same. If Z is different, then it is not same element. So, isobars are atoms of different elements with a different atomic number but same mass number. Examples are given in the textbook. You can refer it. Isotope, very easy example is isotopes of hydrogen, that is protium, deuterium and tritium. And the example of isobar is argon and calcium.
By now we are aware of what exactly the concept of atomic number and atomic mass is. Atomic number is simply the number of protons present inside the nucleus of an atom, whereas the atomic mass is the number of protons and neutrons present in the atomic nucleus. So when we have to represent both these entities for an element, how do we write it? Is there a specific way for representing it? Yes. The chemical symbol of the element is written with atomic number at its bottom on the left side, that is in subscript. On the other hand, the atomic mass is written on the top left side in superscript. Something like this. The symbol of the element, its atomic number and its atomic mass. Now, how do we represent a simple element like carbon? That's right, something like this. The atomic symbol, that is C, followed by the atomic number 6 and atomic mass 12 at the respective places. Now, what if it's another element, say chlorine? Something like this maybe? Yes, one type of chlorine atom can be represented like this. Why did I say one type of chlorine atoms? Are there more types of chlorine atoms? Yes, some chlorine atoms have 20 neutrons instead of 18 in their nucleus. Then how do we represent this type? Yes, just like this representation. However, we now need to understand what exactly that is. There are many such cases where atoms of the same element exist in different forms. These forms are called the isotopes. Yes, in simple words, isotopes are defined as the atoms of the same element having the same number of protons but different number of neutrons. Yes, same number of protons but different number of neutrons. Just as we saw in the case of chlorine, all the atoms have 17 protons, but a few of them have 18 neutrons while some others have 20. So these are the isotopic forms of chlorine. Similarly, several elements have isotopic forms. For instance, we have carbon with 3 isotopes. As we can see here, each isotope has 6 protons but different number of neutrons. One has 6, the other has 7, and the last one with 8 neutrons. We name these isotopes as carbon-12, carbon-13 and carbon-14 respectively. Now this was about the different forms of the same element. But what if I tell you that atoms of 2 different elements can have the same atomic mass? Yes. Let's understand this with an example. We take 5 different elements: sulfur, potassium, calcium, chlorine and argon. Now, if you notice, in each case the number of protons and neutrons is different. It's 16 and 24 here, 19 and 21 here, and so on. That's right. However, the total number of nucleons in each sums up to 40. What do we mean by a nucleon? A nucleon is a proton or a neutron. Yes, each thing present in a nucleus is a nucleon. So the total number of nucleons in an atom is the sum of protons and neutrons. We can also say that the total number of nucleons in an atom is its atomic mass. Yes, understand this well. The total number of nucleons, which is nothing but the sum of protons and neutrons, is the same as the atomic mass of the atom. So coming back to our example, there are 5 different atoms here. Though the number of protons and the number of neutrons is different in each case, the total number of nucleons in each is the same, which means the atomic masses are the same. How? Yes, it's simple math. One of the sulfur isotopes that we have taken as an example has 16 protons and 24 neutrons. So the atomic mass of this isotope has to be 40 units. That's 16 plus 24. Next is the potassium isotope having 19 protons and 21 neutrons. So again, we get the atomic mass as 40 units. And similarly, we get the atomic mass as 40 units in each of the remaining cases. Such atoms, or rather isotopes of different elements having the same atomic mass, are called as isobars. The term arises from Greek, iso meaning same and baros meaning weight. Remember, if we consider 2 isobars, the number of protons and number of neutrons in each case will be different. But the total number of nucleons or the atomic masses will be the same. So far, we've understood subatomic particles and a few important concepts related to atoms.
Thank you for listening, students. Hope it was a useful session. As I already said, please take down the definitions alone in your classwork so that it will be helpful. And definitions should go as per the text. Thank you.